Okay, so we started with a little intro about SpaceX and the Falcon Heavy that just launched. Falcon named after the Millennium Falcon because the guy just loves Star Wars. And then, obviously, he launched his plane out, or his car out into space. Great advertising for Tesla and also good practice. Anyway, we just talked about that for a little bit at the beginning. Now we're getting into, I just did a practice one with them where if we have two sides and the angle in between them, let's say 8 and 9 and 125, you're going to have to know how to find that third side. But what if you were just told this was 8 and this was 9 and this was 4? First of all, is that even a possible combination of three sides that could make a right triangle? I did say something that I didn't mean to say, which makes the answer kind of wrong. Okay, I said, could that be a right triangle? No, that can't be a right triangle because that isn't a Pythagorean triple. A squared plus b squared doesn't equal c squared. But can it be a triangle? How about that? Yes, it can be a triangle. All right, so if this is a triangle, then it's got angles, and I could figure out this angle by using law of cosines, and then I could find its area. But there's a much, much faster way to find the area of this thing, because I don't even have to find that angle. You can skip the law of cosines and all the chances there are for screwing up in doing that. So how do you find the area with just the three sides? A smart mathematician that I believe you would pronounce it Heron, Heron, but you know, everybody gets to decide how to pronounce their own name. So a lot of people Americanize that to Hero's law, and it goes like this. First of all, you have to know what S is. S is a variable he coined called the semi-perimeter. Well, first of all, do you know what a semi does when I say semi this or semi that? Okay, it cuts it in two, right? Okay, so if I say the semi-perimeter, take a guess what I do. Take half of the perimeter. Okay, so what's the perimeter of this thing? 21. Okay, now I'm going to cheat. I'm going to make it just work significantly nicer. I'm going to make this a 5. You know why? Because my semi-perimeter is now what? 22, and it's even, which is going to work nice to divide it in half. You know what I mean? Just because the numbers would be nice for your first time. Semi-perimeter, 8 plus 5 plus 9, and take all that and divide it by 2, because the semi is doing the whole divide it in 2 thing. All right? That would be 22 divided by 2, which would make 11. The semi-perimeter is 11. Now, I'm going to pause for a second. I'll shut a door and get ready here. Okay, so we found the semi-perimeter. And now, the area of this thing, now that you know what S is defined as, area is the square root of S times S minus A times S minus B times S minus C. And take a wild guess what A, B, and C are. They are the sides. So, let's do this one. We have the square root of 11 times 11 minus, it doesn't matter which one I pick first, second, or third. I'm going to go biggest to smallest. 11 minus the 9, which would be 2. 11 minus the 8, which would be 3. And 11 minus the 5, which would be 6. There we go. So square root of 22 times 3 is 66 times 6. It's not going to be a nice number. That's okay. Pause for a second. Let's figure it out. Okay, so the 66 times 6 was 396. So it's the square root of 396, which would be 19.9. Why is that any better? Because you don't have to find any angles. You just can get directly to the area. It's kind of cool. There's a formula for just about anything. There's a cool formula that'll tell you how much colder it gets. That rocket that launched, do you get that it was getting, its tip was getting really cold as it was heading up? Because there's a formula for that. The higher you go, the colder it gets. That's why you go up to the top of a mountain, it's always colder up there than it was on the ground. Okay, there's just a simple direct formula correlating height and temperature. And then if you get up to like 35,000 feet, like where planes fly, like if you could stick your hand out the window, you know, of course it would snap off, but you know, other than that, it would be incredibly cold. It would be actually like 50 below, like 50 below zero up there. And it could be beautiful and hot down, like you're flying to Hawaii and you're going over the Pacific Ocean. It could be beautiful and hot right down there on the water. And if you were on in a boat, but flying way up there, you could be at 50 below zero up there. It's kind of cool. All right, so this formula, Heron, but a lot of people pronounce hero, probably just because it's easier for us to say here in America. Heroes law. All right, so you're ready for this test, and I feel bad waiting this long to give you the test. But one of the things that we need to do today is to do a lab. We're just going to take the measurements for the lab, and the lab is going to be due next week. And it's basically a review, which will help you for this test too, of how to use right triangles to figure out heights. Let's take a super simple question. I put a dot way up at the top there and say, if I'm standing here in the Commons and I look up at the ceiling, it's pretty tall, and I'm like, I wonder how tall that actually is. I can't even draw a stick man. Hold on a second here. So I'm here and I'm looking up at this dot. To get, I'm going to end up creating a right triangle here. It always comes down to a right triangle. Okay, and if it was this simple, there wouldn't be a lab about it because it would be super simple. You tell me, what two little instruments do I need? And I'll be able to tell the height of the Commons. Super simple. One angle and one side. Okay, what do you think's the easy side to get? Yeah, the bottom one. Couldn't you measure this really easy? Just go from here to here, and then figure out I walked 30 feet or whatever. And then all I need is an angle right here. One more little thing. Remember, if I want to be somewhat accurate, I have to include the height of the dude. And specifically the height to their eyeballs. I'm going to say it's okay for you to either use 4 feet, 5 feet, or 6 feet for your own eyeballs, because that'll cover pretty much everybody in the class. There are people that are short enough that it would round to 4 foot for their eyeballs. Okay? Because like, if you're 5 foot tall in the first place, your eyeballs are definitely significantly lower than that, right? So anyway, 4 foot, 5 foot, or 6 foot is good enough. I don't need you to measure exactly what's the height of your eyeballs. Then we have to start including like how thick are your shoes, and anyway. So we have to include this, but do you get, I can just wait till the end, and let's say the kid's eyeballs are about 5 feet. I can just at the end say it's whatever the height of the Commons was plus 5 more feet. You know what I mean? This side here. All right. So let's just do one for kicks. Let's say that I figure out the angle is 60 degrees, and that's 30 feet. Would you please figure out the height of the Commons, including the fact that the person's 5 foot tall? I'm going to pause for a second. It's not going to be nearly that easy, but we'll start with an easy one. Did you use sine, cosine, or tangent? Please say tangent. Tangent, good. Tangent of 60 was equal to h over 30. And I hope you're feeling like, holy crap, that was so easy. Yep, it was. So what was the height? Rounded. Oh, it's a 36. You could have done it another way. Cool, but what's the height? What? 56.9? Oh, okay, that included the height of the person. How about without the height of the person? 51.6, and then you add on the person's height. Did I say that wrong again? I'm going to pause for a second. 51.96, there we go. And then we're going to add on our person's height, which is 5 feet. So then we're at 56.96, or about 57 feet. That would be extremely easy because you just need to find an angle and you need to see how far it is to up underneath the thing that you were measuring. Like, let's say this was one of those little sprinkler heads up on the ceiling of the commons. You just have to walk this distance, super easy. Well, it won't be that easy, of course. But how would we get the angle? Let's talk about that for a minute. If you have an iPhone or an Android phone or any type of a smartphone, take it out right now. We're going to talk about how to find those angles. It also works with an iPad. So if you don't have a phone with you today, you can use the iPad. I'll pause while we do this. So now I showed the kids how they can measure these angles using their smartphone. Or if nothing else, you can borrow my smartphone. And that angle, here's some tips for you for doing this project we're about to do. Everybody, don't just take the data in some random place. Let's open the file where this lab is going to happen. So go into Schoology, find the file called Height of the Commons. I'm going to pause while we do that. Okay, so here's what the file looks like. Height of Commons Lab. Purpose, find the height of the MHS Commons in an unusual way, knowing only a lateral distance. Now, I'm going to show you a sketch of what we're going to do here. See this find the height of the commons sketch? I'm going to zoom in on it a little bit. All right. What I told you would be a super easy way to do it, and yet too easy to make it a lab. Okay, that takes some time to figure out and write up. The easy way would have been to measure all the way underneath the thing, the ground distance that way. That's what we just practiced just now. We had an angle and then the distance on the ground, and it would be like boom, boom, done. Okay, that's not much of a challenge. Also want to warn you, a question like this could appear on your test. So this would be great practice for the test. Why? Because the test has 3D trig involved, like this, where you have to picture triangles all over the place. And the test, it may not have this exact problem, but it'll have problems that are similar, where you got to find a certain distance. All right. So this x, sometimes that can be confusing because that makes you think that's what you're solving for. No, we will know that distance. Okay, that's the only distance we will know is a lateral distance, a sideways distance. So let's say you're standing right here and you sight up, and you and your friend together, you figure out this angle right here is like 60 degrees. I encourage you to have that be a fairly big angle. From our experience, the kids get the best results on this if they walk up close enough so that the angle's pretty big. Like 60, 50, 40, something like that. Okay? If your angle's like 40, 50, 60 or more, just remember if your phone reverts over to doing the from the vertical, you'll have to adjust, but it could even be 70 or 80 degrees. But have this be a fairly big angle when you start, because you're going to be able to start anywhere you want in the commons. Then here's the critical part. From where you sighted, you now must walk at a 90-degree angle. Instead of walking straight towards it, you walk at a 90-degree angle from that. And then how do you measure that distance? There's some blocks in the commons. I'll show you where they are. There are blocks all over the place that are exactly 1 foot long. So as long as you judge by those 1 foot long blocks, you'll be able to tell exactly how many feet over you walked. Next, I would strongly recommend you go at least 10 feet. Again, if you want this thing to work, go at least 10 feet. And then recite. Now think about it. Do you get you are further away now than you were before? And therefore the angle should be a little smaller than it was before. If there's a very small difference, like it was 60 and now the new angle's like 62, I would walk further because you want that difference between the two angles to be big. It's sort of like a sample size thing in math. You know, you get how if you have a bigger sample size, you get a lot better data. Well, if you get a bigger difference between these two angles, your answer will be a lot better. All right, so if this could be like 50 and this could be like 60, that'd be a great combo. At least 10-degree difference. Okay. Can you just go anywhere to start? Yes. And you sight up to something. Here's the common mistakes. Kids forgot what they sighted to. So when they had to go to the next spot, they were like, I'll just pick something else up there. It's not going to work at all. It's not even going to be close. You got to sight to the same thing. So get it straight in your head what the thing is that you picked. Maybe you picked the sprinkler up there. There's these windows. Maybe you pick a corner of a window. That's fine. Just make sure that the thing is at the very peak, at the very height, very top of the commons. Okay? So pick a spot. Don't pick 2 spots. Other mistake I saw people like measuring and then like walking over here somewhere and then measuring again. It has to be at a 90-degree angle or you won't have right triangles. So you have to be careful where you walk. Figure out what straight to the thing would have been and go at a 90-degree angle to that. See what I'm saying? So it's as simple as, let's say you got 60 for this one, 50 for this one, and you walk 12 feet. That would be your data, and now you can figure out how high the commons is. I'm not saying it's as simple as one equation crunch done, but you got a lot of right triangles there. You get the red triangle that would be on the ground. That's a right triangle. You'd have the right triangle. I'll make it out of blue here. This blue right triangle for the second angle we sighted, and then I'll make this one out of green. This triangle for the first one we sighted. And they all share a lot of sides, and you could transfer information from one to the other, and you can solve for the height, knowing only this and this and this. All right, that's your job. We're about to take data. Question first. I get if our goal was just to find the height of the commons, we could do it that other way, and I agree. That's the easy way. So this is the challenge, is about setting it up this way. If this was just about practicality, actually, I'd just call up the building engineer and say, how high is this commons? And he'd say it's 64 feet, and I'd be done. You know what I mean? This is about setting up a challenge for you. So the medium-like level would be if I didn't want to, or the engineer says, I don't know what it is, I'd have to look it up on the schematics. I could go out there, measure, walk up underneath it, see how long that was. I have a side, I have an angle. It would be easy. It's the challenge of it. Okay? All right. So we're going to pause for a minute while we go out and get the data for this lab. So your only homework for today is to start working on the lab and have your other homework caught up. That's the only thing you got to do, is be caught up on your other homework and get this lab started. Have a good day.